we are going to talk about the state of wireless industry as it is this year, 2024. So we will cover carriers and OEMs separately. Carriers are focusing on monetization of 5G at the moment because thus far that monetization has not been very successful. And without successful 5G monetization, there will be no appetite for going forward with 6G. So what has been appealing to carriers thus far? Well, cloud native networks, fully automated, virtualized, they are viewed as revenue generating saviors for carriers. On the other hand, 6G standardization is rumored to be delayed because if they don't properly monetize 5G networks, the carriers really will not be interested in migrating to yet another different standard in any time soon. As far as OEMs, all major OEMs have unveiled their strategy to implement AI in network functionality. There are dozens of diverse use cases that require AI application, and they are of various complexity. And managing such multimodal AI networks is an extremely complex task. So the real question is, will potential cost and energy savings that AI brings offset expenses associated with additional computing resources that are required to run AI networks? Also, the question is, will infrastructure powered by AI be interoperable across vendors? So those are the main dilemmas that we see as OEMs push to bring AI to the forefront of their offerings. Example of AI use cases in network functionalities are listed next. I have grouped them together. The first one and the second one are somewhat related. It's resource planning, resource allocation, resource utilization, and resource optimization. We talked about resource. What we really are thinking about is how we assign those resource blocks to various UEs. And that ties into traffic management, that load balancing, and traffic pattern detection. And I need to point out that really all those how AI is going to predict this is based on the historical data related to traffic management and load balancing and traffic pattern detection. So the more data we have of the past, the easier it will be to predict what those requirements will be. The next one is spectrum management and network slicing. Network slicing is also something that operators see as financially appealing for them, where they can actually assign a part of the spectrum, a part of their network for, let's say, private 5G networks. Then they can then basically lease that to either MVNO or perhaps to vertical and to various enterprises. Network self-configuration, network self-healing is what we used to call sound. And it's a very obvious direction in which AI can go to help with network self-optimization, self-configuration, and self-healing. Another point is customer experience, performance improvement, and quality of service management and customer support. And then obviously there is security threat detection and anomaly detection. Beamforming management is another one that is also tied somewhat to traffic management and load balancing. For those antennas that can do beamforming, it is very important to know which beams are going to be active, most likely to be active during rush hour or during various times of the day, so we can actually manage the beams more properly. And finally, there is power efficiency. When can we shut down, for a moment, our IoTs or our UEs, and that is where AI can help us. Now, as for 5G, a good RAI is fixed wireless access and network slicing, as we have mentioned. As an example for fixed wireless access is Verizon Wireless, and they are using C-band to sign customers to their fixed wireless access residential broadband. And they are directly competing with wireline residential broadband carriers, such as Xfinity, for example. And occasionally, they can sign up so many potential customers that there is no capacity in C-band. In that case, they use 28 gigahertz millimeter wave to offload the C-band customers in those areas where demand is really heavy. So we have seen that. We have seen that in Houston, specifically, which is where I live, where Verizon Wireless has actually used a millimeter wave fixed wireless access to help offload the demand for C-band residential broadband customers. We have also seen the the millimeter wave repeaters that actually help those 28 gigahertz small cells to propagate the signal further. Also, enterprise private cellular networks provide good ROI for carriers. As far as the poor ROI is enterprise neutral host networks, because Wi-Fi is cheaper and Wi-Fi is very well established there, and we have not really seen, for example, in office environment, much appetite for enterprise neutral host networks. As for 6G, carriers do not want 6G hardware refresh, which is hardware rip and replacement. There is simply not appetite for that. And what it really means is that 6G networks will be contained to the existing 5G frequencies. What we don't think is that we will see migration to terahertz, for example, that will require rip and replacement of the hardware. And yet, innovative candidate technologies are being showcased. An example is integrated communication and sensing, which is ISAC. OEMs are showcasing that technology, and that really is making use of massive MIMO antennas to sense the surrounding environment. And that really means that this ISAC technology is effectively a radar. So you're basically sensing your environment and then make a decision as to what beams to use and how to use them. As for devices, smartphones, and wearables, the industry trend is to create distributed computing hubs for homes and small enterprises. And there are two use cases that are associated with it. The first use case is to offload artificial AR, VR computing from devices to the hub. And by doing so, we eliminate the need for power-intensive computer chips and large batteries at the device. That allows device to have smaller form factor. And that also means that the headset manufacturers can create sleek and fashionable products. The second use case is to use a hub for AI computing. And this use case, it offloads AI computing from low-end smartphones to the hub, thus, saving battery and allowing those smartphones to still have the same form factor that we are used to seeing. Deutsche Telekom has unveiled a groundbreaking concept AI phone. At that phone, the user states what they want, and the generative AI assistant executes the task. And this is a fundamental shift in user experience. And Deutsche Telekom predicts that apps will be obsolete in 5 to 10 years and will be replaced with AI assistant. So let's talk about IoT networks. A 5G IoT chip recently has shown to have a reduced battery consumption by 60 to 70% compared to LTE technology chips. This is significant because IoT devices' power consumption has always been critical. And this is additional motivation to migrate to 5G IoT networks. Also, terrestrial and satellite network operators can offer IoT connectivity over a single modem now, and this simplifies billing and operation. And the cellular network here is the primary, and the satellite network is the backup. And what it really means is that IoT network will never be down for as long as both networks are within reach. If one of them fails, the other one is there to take over. And this is very important for mission-critical IoT networks when downtime cannot be tolerated. And finally, let's talk about Wi-Fi 7. The significant price premium of Wi-Fi 7 tri-band deployment is just too hard to justify at this point, because there are no applications that require its advanced capabilities yet. 6G device ecosystem is underdeveloped, and ISPs worldwide are under pressure to reduce capex, and not just them. I mean, all of the telecom industry is under pressure to reduce capex. And thus, so far, most 2024 Wi-Fi 7 deployments are just dual band deployments, 2.4 and 5 gigahertz, but no 6 gigahertz. And this is so because they are cheaper than tri-band. However, IB Research forecasts that it will only be for a limited time, and that in 2028, Wi-Fi 7 CPE shipments will surpass Wi-Fi 6 shipments, and that is in about 4 years. And this is everything that I wanted to present as of the state of the wireless industry. And this concludes our presentations. Thank you very much for your attention, and have a good day. Bye-bye.